In this section, we are going to define and break down certain cryptography related terms so that we have clear understanding of these concepts before we deep dive into the world of encryption. We have already seen why it is important to encrypt the traffic between clients and web servers in the lecture dedicated to confidentiality security mechanism. I would recommend you to visit the lecture on confidentiality to understand the need for encryption. Moving on, encryption provides confidentiality or privacy. We are passing the information back and forth through APIs, file exchange, voice messages, videos, and many other ways. We want to avoid that information from getting stolen. Main aim of encryption is to keep data confidential and not openly available to strangers to read. In the past, I had interaction with solution designers and architects during solution design who had very faint idea regarding when ideally encryption should be implemented. They wanted to implement encryption for all the APIs irrespective of the fact data is confidential or not. Let's imagine an API which returns you country and corresponding country code, or another API which returns currencies and corresponding currency code. This kind of data is publicly available on the internet, and the nature of the data doesn't compromise the security or privacy in any way. Now, should you implement encryption for such APIs? Obviously no, it doesn't make any sense to implement encryption for this kind of data. So the message that I wanted to convey is encryption is required only if message is confidential and it compromises security in any way if the message is revealed or stolen. Let's move on to see how the encryption is designed to work. Encryption scheme has two methods, encrypt and decrypt. In the forward direction, the concept of encryption is you inject the plain text, which is the message that you want to send. We add some sort of secret key that ideally is shared between client and the server. Now we apply some sort of complicated mathematical function, that is algorithm, and output is your ciphertext. So there are three components to it: the data to encrypt, that is plain text, the encryption algorithm, and the encryption key. The key is used by the algorithm in the process of encrypting and decrypting the data. Simply put, encryption process puts a wrapper around the information. Anyone can see the encrypted data, which is meaningless data, but only the person who knows the secret can view the original data. If you intercept the encrypted message, you will not have any idea what the message is. But if I tell you that original plaintext was shifted by +1 character to create the encrypted message or to hide the message, you can easily shift it back and suddenly whole thing starts making sense. In the backward direction, the concept of decryption is we inject the ciphertext, which is the encrypted message. We add the decryption key. Finally, we apply the mathematical algorithm function and output is plain text. Before we wind up this lecture, we will quickly summarize the terms. Plain text is information or data in unprotected or human readable form. It is this information that need to be protected from unauthorized party. Key. It is a string of characters which is used within an encryption algorithm for altering and scrambling the plain text so that it appears random. Like a physical key, it locks or encrypts the data so that only person with the right key can unlock or decrypt. Cipher or encryption algorithm. These are complex mathematical functions that specifies how plain text data should be transformed into encrypted data or ciphertext. The input to an encryption algorithm includes the plain text data and an encryption key, and the output is ciphertext. Actual ciphers that we use today in cryptography is not just rotation, shifting or substitution that we have seen before. Instead, modern encryption uses complex mathematical formulas that we will see in the next lectures. Ciphertext is encrypted form of plain text. A cryptographic key, when combined with an encryption algorithm, scrambles a plain text to create a ciphertext. Ciphertext is unreadable without knowledge of the algorithm and the key. Coming to the encrypt function, or encipher. It means to lock the data using key and encryption algorithm. It is the process of converting plain text readable data to an unreadable form known as ciphertext to protect it. When data is encrypted, the message and an encryption key are passed to the encryption algorithm and the output is ciphertext. Now coming to the last function, that is decrypt, also known as decipher. It means to unlock the data using key and algorithm. It is the process of turning ciphertext back into the plain text. To decrypt the data, the ciphertext and decryption key are passed to the decryption algorithm and the output is plain text. If you would have observed, encrypt and decrypt are just opposite in nature. With this, we end this lecture here and I'll see you in next video. Thank you.